Hi students, this is your 22nd video lecture. This is the continuous video lecture of 21st video lecture. So just I want to continue this topic for more clarification because I covered half of the part address mode PPT. Now I want to cover fully. This is your first topic according to your SPT syllabus in your 4th unit. Address modes. In my previous lecture I discussed about address modes, why we are using address modes, and then some kinds of address modes: immediate address mode, direct address mode. Now I am going to talk about remaining address modes. As soon as possible I want to complete this entire topic within this video. Indirect address mode. Memory cell pointed to by address field contains. Memory cell pointed by address field contains the address of the operand. The address of the operand. We will see everything. What is that? Look in A, find address A, and look there for operand. Add A. Add contents of cell pointed to by a content of A to accumulator. Larger address space is possible. So it talks about how this indirect address mode is working, and the second thing is how this indirect address mode will store the data and how it will take the data based on the size. It is nothing but the capacity or size of the address mode, the indirect address mode. So large address space is possible. So in where any word length may be a nested multiple cascade EA equal to multiple memory access to be find operand. So indirect address. Just imagine indirect address, it has the more space. See, first thing is indirect address mode has the more space. For what? Because indirect address we are not getting direct, that's why it needs a space. Then only, so means what? Go to here, again go to here, again go to here, again go to here. Just imagine, here something is there, above some more box is there, above some more box is there, then we have to store this one, then I will show you everything. Just wait a minute. What is direct and what is the indirect? Okay. Now listen. Here is one shop is there here. Okay, this is shop. Just imagine this shop. And one more shop is here. Okay. And now you are here. And now what is direct address? You can directly can go it. Here one water bottle is there. You can get it. Okay. Now same way you want some more than that is here. Some drinks are there. Drinks are there. Okay, now water bottles are available here, drinks are available. Now you want a drink. Then what you have to do now? Then, if you want to get this drink, like this, yeah, imagine. Then what you have to do? First you have to cross this one. Again you have to cross this one. And finally you go to here. So for this, what? We have to spend more energy. The same way, what I am trying to say here, when you are, now we have to know about this one, where this is, and again we have to know about this place, again know about this place. Because this place, this drinks place, inside of this one, and again inside of this one. So far we want to go here, first we have to go to this place and again go to his place and again go to. For example, I will give you, now we want to go to Patna. Now just imagine you are in China. Now you want to go to Patna. Then you want to go to Patna, something is there to you want to get. Just imagine you are belongs to China. Then what will happen? One thing will happen. What is that? You want to get that particular thing in what is there in Patna. We have to do one thing. That is, first we have to cross your border. What is the border? We have to cross your China borders, and we have to enter into the India. Again, India to Bihar, and again Bihar to Patna. So now you are crossing China to India, again crossing Bihar to Patna. Then you will get, for all these things, you need a more space. It's the same way, indirect address need a more space to store the operand. Look at here. Indirect address, not direct address. If you get the here, this is actually a, okay. So this address, so what is that? For example, here something is there, 5 is there. Again this 5 will store into, again one more thing, okay. Just imagine this box address is this, and again this arrow representing the 5 like this. So what is that doing here? First, this is going to this place. Again something is here, that's why it's going here to here. Okay, then only you will get the content. So this is called indirect address. Previously direct address, but now indirect address. So the diagram representing indirect address in a clear way, crystal clearly we can understand what is indirect address. If we get the thing here, that is the direct address, but we are not getting here, to again here, this is indirect address. Next one is register addressing. In a computer, many registers are there. I already said that. Data register, address register, accumulator, program counter. Okay. And these are all different kinds of registers that are available in a computer. So what is the address register? So address register, often held in a register, simple thing. So R1 is a register and R2 is a register. If you get the operand, that means data, here, then inside of this is the register place, okay, inside of the register we are getting the data that contains nothing but the operand. And then this is called a register address. Where you are getting data? In register only. You put someone in the register, then you are going for the taking of this address, this content, and this address is called register address, simple thing. So look at here. So this is a register actually. Register contains some space, some memory. In this memory you can store some data. Data is nothing but operand. So where is an operand? This operand located in the register. This is called register addressing. Register indirect addressing. So this is similar to the indirect address. So all of you know about the address. All of you know about the direct address. All of you know about the indirect address. All of you know about the register address. If data will contain, the operand will be there in the register, we call as a register address. Now register indirect address, what is that? Simple. I won't show the diagram, that you have to know it, but just you know it. Okay, no need to knowing much for this. Okay, now actually this is the register. Okay, this contains some space is there to maintain the data. This is a register. Just imagine register R1, and here data is not available here, but is this data available this location to some other way in the memory. Means register here, what is a register? Just pointing, it means what? You are asking some doubt to your friend. For example, you are asking your brother, where is mom? Just imagine in your house, you don't know where is mom and what mom is doing. Then in front of your brother is there. Then you want to ask your brother, where is mom? He also doesn't know it. Then immediately he will tell you, I don't know where is she, but I know one thing, that is, a father will know where is mom? So here, his brother not giving any clue, is giving the clue. What is that? Go and ask father, father will tell you exactly where is mom. Okay? This, your brother helping to go to your father, and father will tell you where is your mom is. Okay? That is called a register indirect address. Same way, you are going to here, and again you get the link where is the data content is there. This is called register indirect address. Register indirect address. And next one, displacement address, and relative address, and base register addressing, and indexing, and stack addressing. So these are all address modes. These are all address modes. It will tell you where the operand is available. Operand is nothing but the data is available. Which location and which path the data will be there, data will be available. So all things will decided by address modes. Address modes will guide based on the instruction to get the operand in a particular location of the computer. Just I want to explain about the stack addressing, then we will wind up this class. Stack addressing. All of you know about the stack, yes or no? What is the stack? This is the stack structure. Stack will say about first in, last out, or last in, first out. What is that? First in, last out. What is first in, last out? So stack will be like this. We are going to study about the stack also. What is the stack? Stack is one kind of data memory storage. Okay, but this structure helps us to get the data, retrieve the data, that is first in, last out. Before, or last in, last out, last in, first out, LIFO, last in, first out, last in, first out. What is that? Last in, LIFO. What is the LIFO? Last in, first out. Means, imagine this is the stack, first. Now you want to enter the one. Okay, entered. Again, just imagine this thing, 1 entered. Again 2 entered, again 3 entered, again 4 entered, again 5 entered. So now you want to retrieve data, you want to pick up, you want to take it back, these all numbers. Then which number you want to take first? Which number you can take first? Only 5 we can take first, because you cannot come directly to the 1 until you cross the 5, 4, 3, 2. When you will take away from these locations, if you want to, when you want to take away the 5 from here, when you want to take away from the 4 here, when you want to take away 3 here, when you will take away 2 here, then you can take number 1. Until unless you are not clearing the 5, 4, 3, 2, then you will not take the first element what you entered. That's why this process is called last in, first out, LIFO. We will study about this. So why I am explaining this concept here? Because here we are talking about stack addressing. So how would be the stack address? So stack addresses will be like this. The point is pointing, so it is moving up and down, then it will addressing the places here. So here stack address, again I want to explain you. So top of the stack, this is a stack, imagine, and always the pointer will be top of the stack. This is called top of the stack. Top of the stack, implicit top of the stack list. So here tells you where the operand available. The top of the stack, top. This is this one. What is showing here? No, this one. The top of the stack. This is address. Where the pointer will be located, that is a stack address. For example, the pointer will locate here, this will be a stack address. The pointer will locate here, this will be a stack address. The pointer will be located at the top, then that part will become a stack addressing. This is about the address modes. These address modes we are using for getting of the operand. Operand is nothing but the data. So without having of data, you will not perform any operation, any kind of operations. Okay, data availability is very, very important. For that, we are using address modes to store the data for doing of operations in a smooth manner. I hope that you understand it clearly. So I want some of this one once again, what I discussed till now. So I explained about what is the direct and indirect addresses, what is the register address, and what is the register indirect address, and what is the stack address, what is the index, and these all are the locations where the data available and how the processor can get the data from these places. If the data retrieved by directly, that is called direct address, and data maintains the only constant values, that is the immediate address, and data will maintain the stack type of that, then it will call the stack address mode. So these are the different kinds of mode addressing modes that we are using in computer organizational architecture. I hope that you understand it clear. Even though you have any doubts, you can ask the doubts in my forthcoming online interaction class. Thank you for watching. Thank you so much. So before going to end up this session, I want to focusing on some things here. We can read here and we can prepare in a well manner. If you produce and this summary in your examination, you will get the good marks here. I want sum up here. This is summary. I want sum up here what we discussed till now. So immediate. So operand A. What is telling principal advantage? No memory reference, because immediately we are using immediately, because for that no need to refer, no need to go somewhere, because immediately we are using that one for doing our task. So it is at hand, it's nearby us, we can use it, but no need to tell. For example, someone stand beside of you, your friend stand beside of you, someone asking where is that person, when beside of you, you know to tell the address. Because he is beside of you, that time you will not tell the address, you are showing the person, he is he. You will not tell the address, this is the particular place and this is a particular district and this particular village and particular street. You will not tell all these things, just you will show, and just you will show that person as usually. That you want pointing him. That's called immediate address, immediately. So you will not go for any reference. And second one is the direct. I already said that what is the direct and the indirect, what is the register and register indirect and displacement stack. And principal disadvantages and principal advantages and algorithms. Okay? These things are discussed here. I want to look at here, and no memory reference, not at all. Direct we can get simply, no difficulty at all. And register, no memory reference, because the register is a no memory reference. From the register A equal to R, large address space. Because indirect we have to travel a lot, that's why a lot of address is needed to store. And displacement here equal to A plus R, a flexibility complexity. And stack, a top of the stack, no memory reference, limited accessibility. So these are the summary of address modes. Immediate, direct, indirect, register field, displacement stack. These are the address modes. I hope that you understand everything clear, why we are using address modes, how we are accessing address modes and everything. Thank you for watching. We will meet in our next forthcoming video lecture. Thank you.